I now have the processing system working, it seems like. In a previous video, 2 videos ago, I was having just weird stability issues where I really couldn't debug and walk through code line by line, debugging on the hardware. It was jumping back to main and kind of resetting it felt like. And what I was trying to do was to really test 2 LEDs, which you can now see I have up and running. So real quick, what I have here is an LED that's essentially connected through my tiny little circuit, but it's controlled through one of the ports on the processing system. I also have this LED that in the last video I did a simple FPGA fabric test on the programmable logic side. But now at this point, I still am connected into that really the same pin on the programmable logic side, but I'm controlling it from the microprocessor, the processing system here. So from my code, I am toggling both of these LEDs, and that is successfully working. And so I'll talk through in this video, what did I make for changes to get this up and running. Maybe what I'll do is start with the Vivado, and here on the screen I have that. And just to recap what I currently have for my constraint file, I only have one entry here, and this is just saying use LED 1 on pin Y11, and this is the same pin I used for that last video's FPGA fabric or programmable logic test. So that is not a processing system pin, that's a programmable logic pin. Then beyond that, back to this diagram, this is my block design. And up here I have set up this AXI GPIO so that I could get to that programmable logic pin for that LED. And that's why this GPIO is in here, so that I can programmatically from the Zynq processing system control that programmable logic based LED. In addition to that, I have this pin down here that, or at least this fixed IO, that will let me get to the different ports on the processing system. Now, if I go into the processing system, this is what ultimately resolved the issue for me, is I had to configure the processing system. Previously, I had not really done that, and apparently having the peripheral I/O pins unconfigured, I had none of this checked. It was unhappy with that. So I just went through this. I have a video, quite a few videos back, where I talk about configuring the peripheral I/O pins, but basically I've gone through here and I've told it which pins I'm using for my quad SPI flash, for the Ethernet, USB, SD card, UART, down to GPIO, and within that reset for the Ethernet PHY and USB PHY. And so I configured all of that. I previously had set these voltages, but I did go through and check all this. So now I can go through every single pin here and just validate that on pin 0, it's GPIO. Pin 1 is the flash, pin 2 is flash, 3 is flash, 4 is flash, 5 flash, etc. GPIO, Ethernet reset, and I can kind of see what every one of these pins is being set up to do. So that was done on the peripheral I/O pins. On the MIO, I went into, I've got my memory interfaces. All of this was really set when I set the peripheral I/O pin screen. And that's what you're seeing inside of this. I don't think I changed any other settings in this. Clock configuration, I did set it to a slower speed. And maybe that has something to do with it. I haven't tried bumping up this speed yet. But I will slowly do that as I do more testing. But right now I've got the CPU set to 200. And this is requested frequency in megahertz. The DDR is at 300. I've not done any DDR testing. I have not tried taking this number up on the CPU to, I think it had defaulted to 666. So maybe when I go to higher speed, I'll run into issue, and me setting this lower maybe is what has helped. But I'll do some testing later on that. DDR configuration, I did come in and actually put in the details for not my exact memory part, but pretty close. Mine is essentially this memory part, but a slightly faster speed. So I picked this 125, and I think mine is actually a 107. So running it at the 125 shouldn't be an issue, and I've configured all of that accordingly. But I did all of that. I went through and I did the full generate bit stream. I exported the platform. I came over into Vitus, if I pronounce that correctly now. When I jump over here, then I imported that platform or did an update on this design platform down here, this hardware specification. I did clean up this code a little bit, and that code change isn't what made a difference. Again, what I narrowed it down to is the configuration back in Vivado for the processing system. Oh, and by the way, I am still running the 25 megahertz oscillator into the processing system. And at a later point, again, later this week, hopefully, when I get that part in, I'll bump that up to 33.33. But I'm running 25 for now still because I have not received those parts in yet. And maybe one other side note, when I get to the Ethernet part, that circuit is actually going to provide me a 125 megahertz clock back into my programmable logic. So in the last video, I used a little CAN oscillator up here to provide an oscillator for the programmable logic. But once I get the Ethernet circuit in, it is providing 125 megahertz into my programmable logic. So I'll have oscillators both on the processing system and the programmable logic, and should have some flexibility there. But back to this code, I did take out, really any unnecessary code, any unnecessary includes, and I have this code at this point that basically is doing two things. I'm connecting to the GPIO, that AXI GPIO, that would be for this LED over here. And I'm also connecting to GPIO on the processing system to get me down to this LED down here. And this code just configures it and then writes lows. So I write out basically a high to both the LED here and the LED here. I wait a second, I flip it to lows, and here I just put in a 1 instead of high. I could write it in high. That is equivalent to a 1. And then it just repeats this constantly and never gets out of that loop. And you can see that is running just fine there. Okay, with that, I'm going to go ahead and turn off power and turn my programming cable back on, turn my board on. It's not programmed because the done light is not on. I can also tell it's not doing a whole lot because of the power it's pulling. And then I'm going to come in here, and this time I'm going to go ahead and do a debug. And I can tell it's detecting that cable, so I might have run that a little bit too quickly, but we'll see if it gets my connection established now. So let me just try it one more time. Okay, so at this point, I am programming this, hopefully in debug mode, so that I can hit a breakpoint and walk through the code interactively and debug that hardware. And this is now coming up, and you can see it stopped on this first line of code. And at this point, this light down here is on because there's a pull-up on it, an internal pull-up. This one is off. And on the debug, if I do a step over, which is an F6, I can just kind of generally walk through this line by line. So that's what I'm going to do here. I'll get through this initial configuration to be able to connect to those LEDs. And then this first set says turn them both on. So I just turned that one on. And then I turned this one on, which was already on because of the pull-up. Tell it to wait a second. And then I tell it to turn this one off. And then turn that one off, and that's working. And then I tell it to wait a second and then jump and do the same thing. And I can just keep walking through this by tapping F6. And so that is all working as expected. which is great. So that makes me feel good that I must at least have the connections, generally pretty good as far as between this and some of the other things that I'm doing. Maybe the configuration to the memory, maybe that's helping. I need to still go in and do DDR testing. I've not done that. That's probably the next thing I should do. And then I want to get in this serial connection so that I can program through USB and get rid of this programming cable, and also do things like send output to a terminal output. So I'm feeling pretty good with that. I'll get the faster clock in later this week and just test what I have so far. Then I will come in and probably do the DDR testing next. And then after that, again, connect up this. And I will post an update as I make my way into that part of this assembly. But right now, I'm pretty stoked that this is all working. Debugging as I'd expect it to. Really, I'm getting the results I would expect to see at this point. And then I'll work on testing the DDR at the current speeds, and then I'll start bumping up the speeds and see if that had something to do with it or if there's something else going on.